the solar system appears stable, ordered and predictable. But its origins were catastrophic. Every planet, every moon, every asteroid around you is the surviving result of ancient gravitational violence. I am Binglet Wags, and today we are analyzing how the solar system organized itself. Approximately 4.6 billion years ago, the solar system did not exist. There was only a vast molecular cloud composed primarily of hydrogen, helium, dust, and trace heavy elements produced by ancient stars. Then, something disturbed it. A nearby supernova may have generated a shockwave powerful enough to trigger gravitational collapse. As the cloud condensed, gravity intensified. And as gravity increased, so did temperature, pressure, and rotational velocity. The collapsing cloud flattened into a rotating accretion disk. At its center, matter accumulated with extraordinary efficiency. The proto-Sun absorbed approximately 99.8% of all available mass within the system. The planets were formed from what remained. Eventually, pressure within the core became so extreme that hydrogen nuclei began fusing into helium. In that moment, the Sun ignited. But the formation of the Sun also transformed the surrounding system. Powerful solar winds expelled enormous quantities of residual gas and dust outward into deep space. This event prevented nearby planets from accumulating large gaseous atmospheres, permanently shaping the architecture of the solar system. Inside the rotating disk, microscopic particles began colliding. At first, these interactions produced grains. Then rocks, then planetesimals, massive structures capable of attracting additional matter through gravity. Over millions of years, continuous collisions generated protoplanets, young worlds still incomplete, unstable, and frequently molten. At this stage, the planets resembled oceans of liquid rock and metal. Radioactive decay, gravitational compression, and violent impacts maintained temperatures high enough to melt entire worlds. But gravity began organizing the chaos. Heavier elements, particularly iron and nickel, descended toward the planetary center. Meanwhile, lighter silicate materials migrated upward, forming mantles and solid crusts. This process is known as planetary differentiation. And it changed everything. Without this protective shield, Earth's atmosphere may have gradually eroded into space. And complex life may never have emerged. Yet not all planets formed equally. One invisible boundary determined the fate of the solar system. This boundary is known as the frost line or snow line. Closer to the Sun, temperatures were so extreme that volatile compounds such as water, methane, and ammonia could not remain stable. As a result, only dense materials like rock and metal survived. This region produced the terrestrial planets, Mercury, Venus, Earth, and Mars. Beyond the frost line, however, temperatures dropped dramatically. There, ice and gas accumulated in enormous quantities, allowing the formation of giant planets dominated by hydrogen and helium. Jupiter and Saturn became gravitational giants capable of capturing dozens of moons and immense ring systems. But planets are not static objects. They preserve physical records of their internal history. This is the domain of planetary geology. On Mars, Olympus Mons rises nearly 3 times higher than Mount Everest. It achieved this size because, unlike Earth, the Martian crust remained largely stationary. Elsewhere, some worlds exhibit cryovolcanism. On moons such as Europa and Enceladus, water, ammonia, and volatile compounds erupt instead of molten rock. And unlike Earth, where erosion continuously reshapes the surface, the Moon and Mercury preserve ancient impact scars nearly unchanged for billions of years. They are geological archives of solar system history. And beyond all planets lies another structure few humans ever consider. A boundary separating the solar system from interstellar space itself. The Sun continuously emits charged particles known as the solar wind. This flow expands outward in all directions, creating a vast magnetic bubble called the heliosphere. At its outer boundary, the solar wind encounters the interstellar medium. This fluctuating frontier is known as the heliopause. The Voyager probes required more than 40 years to reach this region. It is, effectively, the edge of the Sun's influence. What appears to be a random collection of planets is actually a self-organizing gravitational system. The solar system was shaped by pressure, temperature, collision, magnetism, radiation, and time. Every planetary surface, every atmosphere, and every orbit visible today is the consequence of invisible physical laws operating across billions of years. The solar system did not emerge from chaos accidentally. It organized itself through physics. The solar system is not merely our cosmic neighborhood, it is a surviving structure of ordered gravity. I am Binglet Wags, and I will see you in the next one.